And the secondary conversion, it's quite traditional. We use circular saw or even mostly circular saws are used for secondary conversion. And however, the recovery again depends, no, the saw blade thickness, because the corp, when we go for secondary conversion, any wastage adds to the price to the timber, because we have already selected the best material from the log. And if you go for any faulty conversion, then we are wasting a huge quantity of timber, valuable resources. So when you go talk about circular saw, the circular saw width itself is around 3 millimeter, and it can every corp, that is the amount of material that is wasted with each cord, can be up to around 5 to 6 millimeters. So it is a huge material as far as the quality of the material is concerned. So with recent technology, it is also possible to minimize the corp. Although in India still we are in a preliminary stage, we are just using laser for carving and carving of timbers. But in Western countries, laser cutting is also being followed, being practiced to cut timber only for secondary conversion, because it is not possible to cut thicker sections with laser. So up to 40 millimeter is not a problem. And the laser has certain advantages. The energy consumption is quite low, and the curve is very minimum here. The curve is around maximum around 1 millimeter. So the so around out of 5 millimeter what we use in circular saw, we can save it and at least 60 to 70% wastage from there. And another benefit of laser cutting is it provides the ease of cutting. We can start the cutting from any point and we can finish at any another point, not like conventional sawing where it has to be from one end to another. But there are certain disadvantages also, because laser cuts the surface by burning the wood. So we end up with a black charred surface, which needs to be which needs to be sanded properly. And even though if you include the sanding as well as the corp, it won't be more than 2 millimeter, because sanding, the area needs, the sanding thickness will be around 150 to 200 micron, not much. So although it's a disadvantage, but still it is beneficial as compared to traditional sawing. And as I mentioned, it is difficult to cut thicker sections, because once you go to thicker section, the laser intensity comes down and we won't be able to get a smooth cut. And one of the biggest problem is smoke production, because it charges the wood. The smoke production is a challenge. However, it can be handled with a proper setup. But at this moment, most laser cutting is used in metal industries, to some extent in wood-based industries. And the second important step after grading and after conversion is seasoning. And it is the most energy intensive process in the entire woodworking processing industry also. And as I mentioned, that as long as a tree is alive, water is very beneficial for its survival. But the same water becomes a culprit when you want to fell the tree and we want to use the wood for any specific applications, because wood is a source of food. It contains cellulose molecules, or cellulose and hemicellulose, which can, with end product of glucose, which is a source of food for any living organisms. Oxygen is already present in wood. So if we provide little bit of water, then it is a very ideal condition for insects and fungi, any biotic agencies to feed on it and degrade it. So seasoning is also one of the important way of increasing the durability of timber. It's a way of preserving the timber by the principle called moisture exclusion. We remove moisture from the wood, so that out of the three parameters, like food, oxygen, and water, if you remove water, at least the biotic agency factors, they will not be able to survive with the availability without the availability of water. So that's the reason it is an indirect way of wood preservation. And it has a lot of other advantages also, because most of the strength properties increases as we decrease the moisture content, and wood also maintains its dimensional stability with reduced moisture content. And for wood preservation, seasoning is also a prerequisite for certain treatment methods, not for like for sap seed displacement it is not necessary, but for most of the pressure methods it is a prerequisite to dry the timber before impregnation. And dry timber also finishes and glues better, and the electrical and thermal properties are far better in a dry timber as compared to wet timber. So although we have a lot of advantages, but seasoning is a very time consuming and energy intensive process, and sometimes people ignore it. And In our country, we have divided the entire country into 4 different zones. So each zone have been recommended with the desired level of moisture, minimum moisture content that we should achieve before putting the wood for use. And there are different seasoning methods, among which the air drying is the most prevailing one as far as in rural areas, because we don't have access to, wherever we don't have access to clean, simply we dry the wood in a timber, in a sunlight, in open air. Although it's possible to dry, however, we don't have a control and we have to depend on the nature itself. If it is a rainy day, then we may not get, the timber may get absorb moisture, and if it is a dry day, it may lose moisture. So we don't have any control on the natural environment, so that we cannot control the degrade also. So although air drying is economical, I mean, we don't put much energy in terms of monetary value. However, sometimes the degrade can be more, and the time consume, the drying period is quite lengthy as compared to other methods. So there are other kiln drying methods. In the basic principle of drying is just wood seasoning is to control drying. We should control the drying so that we can achieve the drying at a shorter period with very minimum degrade. So that is the ultimate aim of wood seasoning. And for that we have different drying kilns are available. So kilns are basically, that depends on in which method we are using to heat our chamber. So it can be steam heated, or it can be electrically heated, or it can be even solar heated. Even we also use dehumidification. Again, the heating can be electrical or steam, but we use a dehumidifier. So these are the traditional kiln drying methods. And recently, in order to, because time is money for industries, so in order to minimize the drying period and with minimum degrade, there are different other methods of drying have been practiced, and some of them are vacuum drying and high frequency or microwave drying, even high temperature and superheated kiln drying, and solvent seasoning. However, solvent seasoning is only for high niche products because it's pretty expensive, because it needs a lot of chemicals. So in case of vacuum drying, in most of the kiln drying, we target the we supply heat from external atmosphere to the wood, so that to allow the water to evaporate from the wood. But in case of vacuum drying, instead of putting more energy, we reduce the pressure inside the chamber. So by reducing the pressure, the boiling point of water decreases, so that wood can be dried at a low temperature. And in case of microwave high frequency drying, I mean electromagnetic drying, we don't target to heat the wood. Actually, we target the water molecules present in the wood. So in presence of high frequencies, these water molecules, they starts vibrating and they produce a lot of energy, heat energy, because of frictions, and because of that the temperature increases, then the water molecule gets evaporated. And it is a bit different than kiln drying, because in high frequency drying the heating actually starts from the center and it comes towards the surface. But in case of kiln drying, it is opposite. Heat goes from the surface to the center. So because of drying, because of these two different way of heating, the drying stresses are bit different in both the cases of drying. And high frequency heating can be very fast, and um, however, microwave drying has to be it can be very energy intensive also, because it is only suitable when you dry the timber below certain level, like when moisture content falls below the fiber saturation, that is around 25 to 30%. Because above that moisture content, if you put the wood for microwave or high frequency drying, it will be very energy intensive, because most of the energy will be utilized just to remove the free water, which could have been used easily even by normal air drying. So it will be advisable to dry the timber below FSP, because drying below FSP is very difficult and time consuming. So in those particular range, if you can put microwave dryings, and it can have a lot of advantages. And just to see what are the energy consumption values for different drying parameters, drying schedules. In conventional drying, the energy consumption can be around almost around 1.5 kilowatt hour per kg of moisture removal. In case of dehumidifying drying, it is around 0.8 to 0.9. In case of solar, because we are not putting any energy, the energy efficiency is less, but we are not putting any extra energy, because most of the energy we are getting from solar radiation. And if you talk about the drying time, the air drying, as I mentioned, it can be very lengthy. It can maybe 3 months, 3 to 6 months. It depends on the drying condition. I mean, environment where the wood is put to dry. Then steam heated kiln can be 10 to 15 days. Dehumidification around 12 to 18 days. Solar kilns 18 to 20 days, 30 days, and vacuum kiln can take 3 to 4 days. So while seasoning is one of the important factor to increase the certain of the mechanical properties as well as the durability. So if you want to promote the wood for a longer period, if you want to use it for a longer period, it is necessary to treat the wood with certain preservatives. So it's a traditional timber. There are certain timbers which are natural durable. However, sapwood of all the species, even if of a natural durable timber also, the sapwood of durable timbers are perishable. So in those cases, if you want to use those timbers, we have to treat some preservatives. Otherwise, they won't last for long period. So wood preservation, the aim is to prolong the life by delaying biodegradation, because we cannot 100% prevent the wood from degradation, because if you prevent from biotic factors, some biotic factor also can degrade wood. But in case of wood preservation, we target the biotic factor, and there are different types of preservative chemicals. They are classified as oil types, mostly creosote and coal tar, but this is very dark in color and unpleasant odor. However, it is easy to treat, and mostly it is used in external applications like in railway sleepers, or even where the soil wood is used in ground contacts. So organic solvent based are also good. However, the solvents are very expensive, because we have to use organic solvents to dissolve the active ingredient. Then there are water soluble type preservatives are predominantly used in wood based industries. There are two types. One is leachable as well as fixed type. So leachable type preservatives are only suitable when we use in indoor applications. But again, leaching is a major problem when it comes in contact with the wood comes in contact with water. It starts leaching from the wood, and the efficacy goes down. And but in fixed type, we can fix the wood preservatives into the wood. But in both these two cases, water soluble preservatives, the another disadvantage is that we have to again dry the timber after preservative treatment, which is again energy intensive. And most of the water soluble preservatives, no, they use heavy metals. So heavy metals are being phased out. For instance, CCA was one of the most important preservatives used worldwide because of arsenic. So they have been now phased out already. Arsenic has been banned. Even chromium as well as chromium is also being put to pressure by different agencies. So these heavy metals are a concern for environmental pollution. And the preservatives can be treated by various methods. It can be by a non-pressure method or by pressure method. If it is easily treatable, then we can go for non-pressure method. Like surface application, we do sometimes soaking, sap displacement method, particularly for poles and bamboo. We do sap displacement, and butchery process. Again, it is only for bamboo and poles in green condition. And pressure method is necessary because most of the timber species are refractory. We cannot treat wood very easily with preservative chemicals. So we have to go for pressure method. So there are different methods, like we call full cell process or empty cell process, depending on how much preservative we want to load into the wood. That guides which method we should follow. So these are the traditional practices what we follow when we use wood for any when we would put wood for any utilization. However, we don't have that luxury of getting primary timbers what we used to get maybe 20 or 30 years back. So we are now ended up with getting small girth timber for plantations. So should we how to put best use of those materials by putting some scientific intervention. So the problems with short resistance timbers are low dimension. That is the one of the bottleneck. We don't get bigger girth. So because of low dimension, conversion sometimes pose problem, and we won't get maximum output also. So the conversion recovery will be less. And sometimes the physical and mechanical properties are also poor because we have higher proportion of juvenile load, because we harvest the timber in 10 to 15 years or maybe 20 years, and the hardwood formation is a bit low, and whatever we are using mostly it is in the juvenile phase. So the physical mechanical properties, even durability properties can be little bit inferior as compared to the primary timbers. And sometimes without the presence of hardwood, the aesthetic value also can be reduced. So these are certain limitations which we encounter with the plantation timbers. And in order to reduce certain these limitations, traditionally we have been following that wood composites concept or engineering wood intervention to maximize the the limitation to minimize the limitation of wood in terms of dimension and its properties. So the traditionally we have been using plywood, particleboard, fiberboard, Oriental Standboard, and laminated veneer lumber, cross laminated timber, as well as glue laminated timber. So these are the engineering products which were mostly used for value addition of secondary species. So plywood, just to briefly tell about all the products. This is made from layer of wood that is called veneers. So we just peel the wood in form of thin layers and then arrange the veneers in orthogonally opposite direction in each layer, and all are bonded with a adhesive. So the adhesive can be urea formaldehyde, which is an interior grade adhesive, or can be phenol formaldehyde or melamine formaldehyde resin. So the aim is to maximize the dimensions of the wood, know what we are getting from plantation timbers. This is one of the best opportunity to get any dimension of material from secondary timbers. Similarly, in case of particle board, we go little bit further degradation of the primary timbers. Like we go for dust, making the wood into particles, and again bind with the help of a resin. You bind it and press it to get a product of desired size. However, they are not structural. They are not meant for structural applications, but for some semi-structural applications, they are mostly utilized. And it provides up even the other option is medium density fiber board. Here we go for further degradation of the material into fiber scale, and the concept again we use adhesives to bind these fibers, and for making products of any dimensions. So again, this product is also not for structural applications. However, it provides the opportunity to utilize any agro-based material for making panels for any non-structural applications. So Oriental Standboard, it is a little bit advanced of the particle board. Here the particle size a little bit bigger, and the particles are aligned, because alignment provides better opportunity to engineer the product as per the requirement. So the OSB is far better than in the material property. It is better than the particle board as well as fiber board. But here instead of particle or fiber, we take bigger size particles or wooden flakes. So LVL is one of the way to get structural member from secondary timbers. I mean, from any timber it can be produced, but it is one of the best way to add value to the secondary timbers, because here thin veneers are aligned in a, unlike plywood, where each layer in opposite direction. Here all the layers are laid in same directions, and the grains are in the same direction. So the material properties are far better in one direction as compared to the other. And these materials are suitable for structural applications in form of beams as well as columns. So when secondary timbers may not find application for load-bearing structures, when you convert into LVL, the LVL can find application in medium to high load-bearing applications. And in recent year, plantation timbers can be also utilized for putting them by making cross-laminated timber. Here it is just like plywood, but however in plywood we always go for veneering. We take a thin sheet of wood. Maybe the thickness can goes up to 1.5 to 2 millimeter. But in case of CLT, we don't need a peeling lathe. Thicker material ranging from 1 centimeter even to 1 inch can be utilized, and they can be placed in the same way like veneers in the alternate layers, and like plywood, and it can be bonded with cold setting resins, because we always require as the thickness is more, we cannot apply hot pressing here. So hot setting adhesive cannot be utilized in this product. Cold setting adhesives are preferred, and this can be made into massive structures. And in recent year, CLT has been finding applications in high-rise buildings, and the advantage is that it can be prefabricated in the factory itself, and it can be taken to the site and erected there. and the construction time and as well as the pollution can be drastically reduced. While CLT gives strength in both the directions and it can be a massive structure, but GLT are mostly for load-bearing applications in form of beams and columns, and even in core members also. So in this case, it is equivalent to laminated veneer lumber (LVL). However, instead of veneers, we are using planks. So the advantage is that compared to LVL, we have very less number of blue lines, so that the emission effect. I mean because in bonding plywood composite industry, adhesive is the most expensive part. So if you can reduce the number of glue lines, so it can have better economy in terms of product cost as well as acceptability. And although it is not a composite, this is one of the best way to utilize small girth timber, because finger jointing can provide the opportunity to use any small timber to make larger dimension product. So with this although the finger jointing can itself be used for any member, making any member of furnitures. However, this can also be utilized for making CLT as well as GLT, because there the small timbers can be joined together and the lamina can be prepared by finger jointing. So it has both direct application in case of composites as well as for direct use in structural, furniture industries. So one of the another way of to add value is by wood modification. Wood it is bit different than traditional wood preservation, because in case of preservation we always aim at putting some toxic chemical into the wood so that the biotic agent they cannot feed on the wood. However, in wood modification we don't put any toxic chemicals. We just change the chemistry of the wood so that the biotic agents, particularly fungus and termites, they won't able to no, they don't find the food source in wood, so that they cannot invade the wood. So wood modification has been commercialized. Among the most important wood modification processes, the thermal modification is one of the most environmental friendly method, because we don't put any chemical into it. You just use temperature, high temperature to treat the wood, and with high temperature, there are certain chemical changes happens in the wood, and that makes the wood be durable. And mostly, largely the timber is exposed to a temperature range between 160 to 240 degree with limited supply of oxygen. So, although some of the properties like aesthetic value, durability against decay fungi increases, and the color also improves. But it has certain limitations because it affects the mechanical properties, and the strength loss can be around 20 to 30% depending on the degree of modification and the temperature exposure. And however, it finds a lot of application in external weather, because it is dimensionally very stable and it absorbs less moisture as compared to the untreated wood. However, this thermally modified wood is not suggested for structural applications, because there is a huge strength loss after, as I mentioned, around 20 to 30% strength loss. So it is not meant for structural applications. The other commercial processes that has been already in practice is acidulation, because wood already contains acetyl molecules around 1 to 3%, and it was found that if we can increase the acetyl content in the wood to 15 to 20%, we can improve the durability properties. So the prime aim was to improve the durability by acetylation method, and the advantages of this method is that it does not change the color of the wood. The color of the wood remains the same, and the chemical is not very toxic. And the wood, treated wood, is comparable with CCA treated wood, and the dimensionality is very, very stable. But one of the disadvantages is that the modification is a bit expensive, although it has been commercialized, but still it needs the chemical consumption is quite high, and the impregnability of certain timbers are also a bottleneck, because the wood needs to be impregnated then treated, so that can be a bottleneck. And but it has very minimum effect on the mechanical properties. Another modification that is already commercialized is modification with the Forfree Alcohol. The Forfree Alcohol is a byproduct of sugarcane industry. It can be obtained from bagasse, corn cobs. It's basically biological material, bio-based chemical. So the process is pretty simple. The chemical is impregnated. Maybe uh, the solution is prepared on 25 to even you can go up to 75% concentration of this solution with water. Then it is impregnated, and after impregnation, it is heated in chamber just for 6 to 8 hours. After that, the wood the chemical gets cured inside the wood, and the cured wood, I mean treated wood, is biologically very durable against biodegrading agencies, and it has been reported that it can be upgraded to class 1 timbers and improves the decay resistance, and it is highly resistant against marine borers, and it provides high level of dimensional stability, and the leachets are also not environmentally hazardous. So these are some of the applications that has been where Forfree alcohol modified wood has been put to use. And there is a company also that they manufactures this wood. They call I think Aqua is acidulated wood. I'm just forgetting the name, but it has been commercialized already. So I just want to highlight here because in future we are going to get only the secondary timbers, because we don't have the luxury of getting primary timbers and utilizing them without any no treatment or anything. So instead of questioning the properties of timber what we are getting, it is better to subject the wood to certain value addition in terms of maybe preservative treatment, or maybe composite technology, or in form of wood modification, and utilize those materials so that we can have very less effect on the natural forest, which is only meant for biological ecological balance. So so I would suggest that in future when you talk about plantation timber, we should not question that this wood is very inferior. We should see how it can, the property can be, if agriculture residues can be put to applications, why not every wood can be put to certain end application with technological intervention. Thank you for a patience hearing, and I'll be happy if any question is there.